Hi, my friend. I hope you are doing fine. Welcome to Joey's Tech. I am your friend Joey. And in this video of Joey's Tech, you are going to learn the problem of maximum sum of a path in right number triangle. I'm sure you are going to love this problem because this TP problem will do the task of making your foundation rock solid, which is necessary when you want to scale to greater heights. I'm sure you are excited to see its problem statement, so let's check it out. So you are given a right number triangle. Now what is a right number triangle? It's basically a right angle triangle but filled with numbers, nothing complicated, nothing difficult. The task is to find out the maximum sum of numbers when you are asked to traverse this triangle from its tip to its bottom. Now these numbers forming the maximum sum are going to exist on one of the different paths you see in this triangle. So you are going to be asking me, Joey, what's a path? Okay, so I start from this one, then move to 2, then 1 over here, and finally 5. This is one of the paths from the tip of the triangle to the bottom. The condition, which is the soul of this TP problem, is that you can either move down from the current position or to the position that is diagonally opposite to the current position. So if I am at this 2, then I can move either to the position immediately below or to 3 that is diagonally opposite to 2. Finally, the path that is going to give the maximum sum is 1, then this one in the second row, the 4 in the third row, and finally 5 in the bottom row. You can see that I am sticking to the condition given. The maximum sum obtained will be 11 and we are going to find it out by constructing a dynamic programming algorithm in our framework. But before we switch to our framework, I request you to subscribe to my channel if you haven't done it already and hit the bell icon because that way you get notified whenever I release videos like this in the future. Now let's move to the framework. So this is the right number triangle that represents the problem. You can see that these are numbers filled in a certain way in a two-dimensional array or a table. Hence, I'm going to use a table or a two-dimensional array, whatever you want to call it, to construct the solution of this problem. This last row over here is going to give us the solution to this problem. We are going to use the dynamic programming technique. So we'll start with the first subproblem by filling this cell, by filling the value of this cell that represents our base state and also our first subproblem. So let's start filling this matrix. So I'm going to straight away put in this cell 1. Now as I told you, this is the base state. So you have to imagine if only 1 had been there in our right number triangle. So what would have been the sum of numbers? Obviously 1. That is why I have filled this cell with 1. That also represents our base state. Okay, now we come here. Now to fill the value in this cell, we'll have to examine this cell because this cell of the solution matrix corresponds to this cell of the problem matrix. So we can reach this cell from here. We have to keep the condition in the mind. Alright, so if we start from here and we reach here, then what is the sum of numbers going to be? It will be 1 plus 1, 2. Okay, now let's fill the value of this cell because we have a value here. Alright, so we have 2 over here and at this cell we can reach from here. We are sticking to the condition. The condition says that yes, you can travel diagonally opposite. So what the sum of numbers is going to be here? It will be 2 plus 1, 3. So in this way, we have solved our second subproblem. This is the right number triangle that we can imagine as a part of our second subproblem. Now we move here to the third row. So to find out the value of this cell, we'll have to examine this cell. So from which cell can we reach here? We can reach this cell to this 4 from here. Alright. So what we are going to do? We are going to add this 4 to this 2. That means the value of the second subproblem because this cell, our solution cell, contains the optimized solution of the previous subproblem. We are using dynamic programming, so we are going to use the optimized solution of the previous subproblem. So this 2 added to 4 is going to give me 6. Okay, now let's calculate the value of this cell. We move over here. At this cell, we can come from here as well as from here, because from this cell we can travel immediately below. From this cell we can travel diagonally opposite. So we are going to have 2 candidates for this cell and we need to pick out the maximum. Alright, let's find out the first candidate. So first candidate is going to be 1 plus 2, which is going to be 3. Okay, so I put 3 over here. Then I put a comma for the second candidate. Make space for the second candidate. Okay, so what the second candidate is going to be? It is going to be 1 plus 3. So it will be 4. Alright, so which is maximum out of 3 and 4? It's 4. So 4 stays, 3 gets eliminated. Let's examine this cell. At this cell, we can only come from here. We can only reach this cell from here. Alright, so only one candidate there will be for this cell. So it will be 3 plus the value of the previous subproblem, which is 3. So this is going to give me 6. Now, had this been our problem, alright, we would have picked out the maximum value, which is 6, and that would have been our solution. Okay, but we have one more row, so we are going to proceed further. Okay, let's quickly calculate the value of this cell. So at this cell, we can only come from here. We can jump from this cell to this cell only. We cannot come to this cell from here. So the value of this cell will be 2 plus 6. It's going to give me 8. Cool. Now at this cell, we can come from here as well as from here. So we are going to have 2 candidates. So the value of the first candidate will be 5 plus 6. That is going to give me 11, comma. The second candidate will be 5 plus 4, and it's going to give me 9. So out of 11 and 9, which is maximum? Clearly it's 11, so I'm going to put 11 over here. Now coming over here, again, we can come to this cell from here as well as from here. Okay, so we are going to have 2 candidates again. So what those 2 candidates will be? 0 plus 4 and 0 plus 6, which is maximum out of 4 and 6? It's 6. Great. To calculate the value of this cell, this is the final cell that we are going to examine. We can come to this cell from here only. So 1 plus 6 is going to give me 7. Okay. Now my solution matrix is filled, and what I have to do, I have to examine this last row and pick out the maximum value. So what is the maximum value? It's 11, and that is our answer. So to find out the path, we are going to trace back. So we added 5 to this value and then only we got 11. So the second cell will be this, and this 6 came when we added 4 to this 2. Alright, so our path is going to include 2 as well, and this 2 came when we added this one to this one or this one, and this is our path. This is the path that is giving the maximum sum. Now we are going to see its algorithm, so let's check it out. Alright, to find the value of the current cell, we add the value of the same cell from the problem matrix first to the value of the cell diagonally opposite in the backward direction, and compare it with the sum of the value of the same cell from the problem matrix and the cell immediately above. So whichever is maximum, we fill the current cell with that value. Now this is for any normal cell, but for the border cases, that means the first cell of any row, you need to keep in mind that there won't be any cell diagonally opposite in the backward direction. Therefore, you need to code specifically for it, otherwise your program will give runtime exception. Similar is the case for base state and the final cell of every row. Finally, you find out the maximum value from the last row of the solution matrix, and that gives you your answer. So this concludes this video. I hope you enjoyed watching this video. I hope you learned from this video. I look forward to help you with programming and algorithms. And only for this video, goodbye and take care.